This is what dreams are made of.
So if you have just come for the videos, you can skip to. So hello my mates. It's been a while since I have posted. It was last time, I guess it was 2020, just before the COVID-19 pandemic, and I haven't been active since then because I was way too busy for my graduation and all. Yes, I am a chemistry graduate as of last year, as of August 2022. So you can congratulate me if you want. I will continue to make some videos about some chemistry related topics that I have liked or that I haven't studied before, but I will study to teach you and show you the topics experimentally, as well as I will explain the theories. Let's go. I have been studying Italian. I have been learning Italian for about 367 days, for about 1 year, and I can speak a little bit of Italian now. My vocabulary is about of 650 words. So let me give you a demo as well. Ciao, sono Kaushik Adhikari. Sono un ragazzo semplice. Sono un juventino vero. Sono un cristiano. Ho studiato chimica. Parlo un poco di italiano. Scusami per gli errori. Grazie. Grazie, ciao. Now let's move on to the main section of the video. So today we will be discussing the Maillard reaction. You have heard about Maillard reaction from various cooking channels and various science channels or chemistry channels as well. Maillard reaction is the non-enzymatic browning of carbohydrate and protein. Yes, in this reaction carbohydrates and protein react. By protein I mean amino acid in particular. They react to form melanoidin type compounds and some other compounds as well. There are a lot of reactions that take place, and by these reactions non-enzymatic browning takes place. Okay, so what is non-enzymatic browning? Non-enzymatic browning does not involve enzyme, as you can guess from its name. So another example of non-enzymatic browning is caramelization. When you make caramel from sugar and you add some water to the sugar and heat it to a certain temperature, I can't recall the temperature, it's about 170 degrees Celsius I guess, and at that temperature browning occurs and you get caramel. So it is not like that, and of course during Maillard some caramelization, some just normal caramelization also takes place, because most substances also contain carbohydrates as well. Now Maillard reaction is fairly complicated to explain, okay, and let me tell about one example of enzymatic browning. Have you cut an apple before, and have you left it for about 30, 40, 50 minutes? You will see that it will get browned over time. So it is an enzymatic process. The substances from apple react with oxygen in presence of the enzyme to brown it, okay. So Maillard reaction isn't like that. It occurs in presence of heat or in presence of base or some substance like that. So I will show you some demos with by browning onion, by making an omelette, and by frying chicken breast, and then I will explain the mechanism of it. I will show which compound is the main one that is formed, and I will tell about acrylamide formation. Acrylamide is a carcinogen which may also be formed during Maillard reaction, and it should not be trifled with, and so you should be aware of what is being formed, and you should always maintain the temperature. And I will then discuss about the effect of pH on Maillard reaction. So let us move to the next section. Ciao. So we are going to try the Maillard reaction today as a practical. So we will take 3 sets. One neutral medium, one will be in acidic medium, and one will be in basic medium. So let's fry the onions and check the effect of pH on the Maillard reaction. Okay. some salt is added. Now let's make the mediums. So this is our basic medium. I have added some baking soda. This will be our neutral medium, and I will add some lemon juice or vinegar to that one. So that's our acidic medium. Now let's cook. So the result is evident after about 2 minutes. The basic medium, the onions in the basic medium has already been caramelized, not really caramelized, but participated in the Maillard reaction as well as caramelization. The neutral medium has slightly caramelized or participated in Maillard, and the acid medium, the onions in acid medium did not react at all or did not brown at all. So the Maillard is now tried on an egg. Let us make an omelette from egg and check the effects of Maillard reaction on egg. As you know, eggs have protein and lipids like glycolipids, and glycolipids obviously have glucose and sugars, and they will react with the amino acids of the protein to proceed the Maillard reaction. Okay. So after about 2 minutes, let's see. Let's flip it. So this part has been browned quite well. This is because of the Maillard reaction. We will discuss the mechanism in the later sections. Now the Maillard reaction is done on chicken breast. So as you know, chicken has a lot of protein. Also it has glycolipids like eggs. So the Maillard reaction will also go on. One thing is to be noted that not all foods react to baking soda or addition of base like onions do. So onions are special in that case. Or I don't know about all foods, but I know about onions. And for chicken and egg, you don't really need to add a lot of base or anything like that, but you must avoid acid medium or marination, acidic marination for the Maillard reaction. Okay, just do it in neutral medium. So after about 4 or 5 minutes, let us see. So this part is caramelized to some extent and participating in Maillard to some extent, as it is evident from its brown color. And let us see the effect on the other side. Let us come back after about 5 minutes. So let us pause. I have left it there for about 5 minutes. Let us see the other side. So the part which was in contact with the heat has been browned very well. Okay, so our experiment is done. Now let us discuss the mechanism in the next section. Ciao. So before discussing Maillard reaction, we must understand that Maillard reaction does not occur with sugar only or carbohydrates only. It occurs between an amino acid and reducing sugar. The important aspect is the reducing sugar, and it occurs only in base medium. Why? We will discuss it a little later. So reducing sugar, the most common example is glucose, and because it has free aldehyde group in the open form, obviously not in the closed form or cyclic form. And fructose can readily be converted to glucose, so it can also participate as glucose in Maillard reaction. So let us discuss the mechanism of Maillard reaction. We have nitrogen, the amine group of amino acid. It has 2 free electrons. It acts as a nucleophilic site, and it attacks the carbon oxygen double bond of the reducing sugar, which is the electrophilic site, and this bond opens up we will get this intermediate. Now positive charge on nitrogen. Now nitrogen, which is an electronegative element, doesn't like positive charge on it, so the oxygen will take this proton, and after hydrogen transfer we will get this intermediate. Now OH minus is a bad leaving group. Why? Because OH minus isn't as stable as H2O thermodynamically, obviously. So from the medium, there in the medium there is BH plus. BH plus means protonated base, and from there it will take H plus and it will become OH2 plus. The leaving group OH2 plus is a very good leaving group. Now nitrogen will push its lone pair over to carbon to form a double bond, and OH2 plus will leave as H2O in the medium. And since we are heating the food, H2O will be boiled off, so the reaction won't go back to the backward step. Now positive charge on nitrogen isn't favorable, as I have said earlier. So what will happen? The base we have used, like baking soda, etc., the basic part of that will take this proton, it will be eliminated, and we'll have that carbon nitrogen bond, and it is called a Schiff base. Also, it is also called a Schiff base. A Schiff base is formed by the reaction of an amine and a keto compound or an aldehyde compound. This is unsubstituted glycosamine or a imine. Imine means carbon nitrogen double bond. Glyco part, the name the glyco part of the name comes from sugar, and amine comes from the amine, obviously. It will undergo imine and amine tautomerization. How? Nitrogen will take this proton again to form this unstable intermediate with positive charge on nitrogen. Then what will happen? So it has another proton over here, and we have the base here. The base will take this proton, this electron density will be pushed over to carbon-carbon single bond, and it will become a carbon-carbon double bond, and this carbon-nitrogen bond will become a single bond, and the positive charge on nitrogen will be eliminated, and we will get this 1,2-enamine, which is an enamine or enol. Why enol? Because it has carbon, the OH is on carbon-carbon double bond. Okay, so then it will further undergo keto-enol tautomerization. We know the keto compounds are much more stable usually than the enol counterparts. How? So this oxygen will push this electron here, because carbon oxygen double bond is much more stable than carbon carbon double bond, and it will take this carbon over here will take this hydrogen from the BH plus. BH plus is the protonated base, and after keto, after that it will form this intermediate here. This is an unstable intermediate, of course, because oxygen is protonated, and it is not favorable at all. So the base will take that proton, and we will get this Amadori compound or keto compound. Wait a minute. Yes, this compound. So this is the primary reaction here. After many steps and many other reactions, this is Amadori rearrangement is one of the reactions only. So after many reactions, we will get this compound. This compound is called melanoidin. Melanoidin is responsible primarily for the brown color and some of the taste and smell also. So several other compounds are formed I will show them in a slide, but I won't discuss their formation. So this is melanoidin. As you can see, the structure is quite complicated here. So let us discuss the formation of acrylamide, the villain of the story. So this is one of the intermediate compounds, as we have seen before. We will represent this part, we will represent this part as A for simplicity. Now we have this compound, okay, and when we heat this intermediate violently, the CO2 will be eliminated because it is a stable compound, and entropy will increase because CO2 is a gas, and we will have this carbon nitrogen intermediate, this carbon nitrogen double bond. After vigorous heating, this bond will break and we will have acrylamide. Acrylamide is very toxic and should not be consumed or smelled. Now this reaction primarily takes place when we heat starchy foods like potato, etc. Why? Because potatoes not only have starch, but also they have asparagine as an amino acid, and asparagine primarily takes part in this reaction. So we should keep our eye on the temperature of the reaction and shouldn't heat our food too much. Now let us discuss the effect of pH on Maillard reaction. You may have heard many chefs adding a base to the food or the substance which is being heated to accelerate its Maillard reaction. As I have also shown it before, you have seen it from me too. Okay, so why not acidic medium? What's wrong with acid? So first let us talk about the forms of an amino acid. It exists as this protonated form and this deprotonated form. This is mainly found in acidic medium. This is mainly found in basic medium, and this is found at pi, or the isoelectronic point. So what's special? In this form, the NH2 group, which was our nucleophile, is blocked. So since it is blocked, it doesn't have any free electron to attack the CO, the keto group here. It is blocked here, right? So now if we add base like baking soda or something edible, obviously we will use an edible base here. So after adding the base, this form will be the majority form, the predominating form, and this form has free NH2. This form has free NH2, and obviously free NH2 means free lone pair, and free lone pair acts as an electrophile to attack the carbonyl, and thus this reaction takes place. I have written the thing over here. Okay, so thanks for watching. If you have liked the video, you can like, subscribe and comment, and let me know your thoughts. You can suggest me ideas in the comment section below, or I will provide my secondary email address in the description. You can suggest me your ideas there, or you can contact me via Instagram. I mostly stay active on Instagram as a social media. You can DM me your ideas there too. Our next video is regarding something like this. You can make a guess. So ciao.